Hello everybody, welcome to this next video on artificial neural networks. So in the last video what we saw that what is an artificial neural network, right? Or what is an artificial neuron. In this video we will be working on how we can mathematically write the output of a neuron, output of a of an artificial neuron. Okay, so basically we this is a structure we discussed last time, that you have a cell body. This is our cell body here. Okay, so here is my cell body, and here are my inputs: x1 with weight w1, input x2 with weight w2, input xn with w and weight, and there is one more term which we call as bias term. We assume that the input is 1 with weight b. Okay, so now the question is, why do we add a bias term? We'll discuss it later when we will be discussing what are our activation functions. So here sigma is the weighted sum. So what it will do, it will take x1 w1, x2 w2, xn wn, and then 1 times b. So this thing here will do x1 w1 plus x2 w2 plus so on xn wn plus b, and then this will work on it and we will get our output, right? So now, because we also saw that we will not have only one single neuron, there will be millions, like there will be many neurons, not millions but many neurons, right? So we would like to have a system to write our output, right? So here you see, if I write my weight matrix, weight vector as w1 w2 wn here, and then I write x vector as the vector of my inputs. So this is my vector of weights and this is my vector of inputs. Okay, so in this case you have only one neuron. We also call it as a perceptron, right? So what will happen? Can I write the weighted sum will be, I just told you, you see the weighted sum will be x1 w1 here, and then you have w2 x2 here, and so on. You have wn xn here, and then you have b times 1 here. So can I write it like this? w1 w2 wn times x1 x2 xn. So I have, this is as 1 cross n vector and this is n cross 1. So when you multiply this and this, you'll get this thing here, right? And then you add b. So what is this vector here? Row vector w1 w2 wn is nothing but w transpose, right? So this I can write it as w transpose x plus b. So that means the weighted sum can be written like this, and then my activation function will work on this. So we have w transpose x plus b, right? And somewhere you will see that people also write it as x transpose w plus b. This will work when you have only one perceptron. It is not a problem. Okay, so we will always say that if phi is our activation function for a single perceptron and w is the weight vector and x is the input vector, then w transpose x plus b is the bias term. Apply the activation function, and this is the output of a single perceptron or neuron. Output of a single neuron, right? Now let us look at when you have more than one neuron, when you have more than one neuron or perceptron in your artificial neural network. So in that case, what will happen? Suppose here I have taken an example. Suppose this is, I have this as my, you see, one way of writing is like this, that this is your cell body where you have a summation and an activation function, and you are saying that x1 is the input, w1 is the weight. But I can also say that this is a neuron, there is a neuron, and then there is a weight w1, there is another neuron which has weighted sum and activation function, but this particular neuron is just the input neuron. It means that it takes x1 and brings out x1. So we call them as input neurons. Okay, so the first layer of neurons will be simply the input neurons. That means whatever you feed, it will come out as such. For example, here I am feeding x1, it will come out as such. Here I am feeding x2, it will come out as x2, right? So these are my input neurons. Fine. Now you see what is happening. Here are the weighted sum, weighted sum, weighted sum, and then you have activation function, say phi. The activation function may be different also. And this is our bias term, right? So now we define weights as Wij. So this notation should be understood. Okay, so here we put I for the input neuron and J for the destination neuron. For example, if I'm going from here, this is my first input neuron, first, and I am going to this first. So this will be W11. And now from first, I am going to the second neuron. So this is my first neuron in the first layer, second neuron in the first layer. Then this is my first neuron in the second layer, second neuron in the second layer, and third neuron in the second layer. So can you see this weight will be called as W11 because it is starting from 1 and going to 1. This weight will be called W12. It is starting from 1 and the destination is the second neuron. And here the input is the first neuron and the destination is the third neuron. So we call it as W13. Okay, I hope that makes sense. Let me change the color and we will just look at here. Here you see, now if you go from here to here, this dotted line, can you see? This will be because you are going from second towards first. So it will be W21. And here you are going from second towards second. So it will be W22. Here you are going from second towards third. So it is going to be W23. Okay. So we have how many weights? We have 6 weights. So for the input neuron, so you have 2 input neurons and 3 output neurons. So what you will do, you will write the first corresponding to the first input neuron, you write all the weights. So you have W11, W12 and W13, and then corresponding to the second neuron, second input neuron, you write it as W21, W22, W23 in the second row. So you get a matrix which is 2 cross 3 matrix. Okay, and then your inputs are x1, x2. So make a vector, and now if you do W transpose X, you see what will happen. If I take the transpose here, so I'll get W11, W21, W12, W22, W13, W23. So this is going to be a 3 cross 2 matrix, and you can multiply it with the 2 cross 1 vector. So you see what you'll get. You'll get first row, first column here, then second row, first column here, then third row, first column here, right? So you are going to get a 3 cross 1 vector. Fine. So now you have your bias term. Bias term means you will have weights. So from here you will have weight B1, and then for the second one you will have weight B2, and then you will have B3, right? So now you have B1, B2, B3. So you add that vector. If you add that vector, so you see what you will get. You will get W11 x1 plus W21 x2 plus B1. So now do you see for the first output neuron here, what do you expect? Let me just take the black color. Okay. So for the first output neuron, what we expect W11 times x1, then W12 times x2, then you want B1 times x1. So that is what you are getting here. And similarly, for the second one, you will get W12 x1 plus W22 x2 plus B2. And similarly, W13 x1 plus W23 x3 plus B3. Right? So this is what our weights will be. Right? So, and then like weighted sum will be. So these are the weighted sums. And because so this will be the output before the activation function is being applied. Now you can apply the activation function on it to get your output here. Okay, so that makes sense. So it means that even if you have 2 layers, you can simply write phi of W transpose X plus B, but the construction of W should be clear. Now suppose you have 3 layers. Okay, in that case we will do the same thing again. Here also, suppose this is my input layer, and this is my output layer, and we call it as hidden layer. Okay, so in between you will in between the input layer and output layer you will have a hidden layer. So here you see you will have W11. Talk like you have to speak out with me so that you understand. So here the destination is 2 and the input is 1, so W12, then W13, and from here you will have W, you are starting from 2 going to 1, W22, W23, and then here you have W, you're going from 1 to 1, right? W11, W12, W13, W14, and then you have here W21, W22, W23, and W24, and similarly you can have from here W31, and then you see W32, and then you see W34, and then you see W33 and W34. Now you can see that this is a scary looking pattern. If you don't have matrices, it is almost impossible to handle them, right? So here what we are making for the first input neuron, this is my row. Okay, for this input neuron I'll collect W11, W12, and W13, and then for the second input I'll collect these W21, W22, W23, and similarly here for the first neuron, here this is my first neuron, I collect this, and then for the second neuron I have this second layer. Okay, this one here, and for the third neuron, this is my third neuron, this is my third layer. Okay, now because these weights will be different, so we can separate them by putting this. This denotes that this is our first layer to second layer, and this is from second layer to third layer. Okay, so we can put a superscript to separate, to distinguish our weights, right? So now if I go from this to this, all I have to do is just use this matrix. Let me call it as W1, W1 transpose X plus B, and then 5 will work on it. So this becomes my input for the second layer. So this will be my X, let me call it as Y. So this is my Y. So now for the second layer, I just have to use this matrix W2 transpose Y. Okay, so Y will be a vector plus B, right? So B here maybe call it B1 and call it B2. These are bias terms, right? And then the activation function. So you see, this is so simple. When you have matrices at your disposal, then you can simply write your output as W transpose X plus B, where W is carefully constructed matrix of weights, X is your input, and B is your bias vectors. Okay, so this is very important. We will see that as we progress in this course, this is going to be very much helpful. Okay, thank you. So in the next video, that is important, we are going to talk about activation functions. Thank you for watching. Stay tuned. Please share this video and subscribe to this channel.